All right, so three-dimensional problems. All right, so three-dimensional problems can be a bit tricky visualizing what's going on. Um, so one strategy that you can use is to identify triangles in the diagram, take them out on the main figure, then calculate your lengths and angles. So when the big issue with this is three-dimensional, paper's two-dimensional, so you got to somehow visualize what's going on. So let's have a look at some examples. Actually, one example with a few parts. All right, so here we go. So a diagram shows a square-based pyramid. The base has side lengths of 6 centimeters and slant edges at each 10. Find these things. All right, so here's our diagram there. So that's supposedly three-dimensional. All right, so square-based pyramid. Yep, square-based pyramid. So that is our square-based pyramid. So that's sitting flat like over it's sitting flat. Can't find anything flat here. This is, all right, there it is, sitting flat. And then we've got top up here and we're going up to those spots. So we've got to try and figure out what's going on. All right, so on this here called V for the vertex at the top. All right, and this line E that I've put down there, that I haven't actually marked it, but that makes a right angle with the base of the pyramid. All right, so if I put a dotted line across here, you can put dotted lines lots of places, makes it a right angle. All right, we can get rid of those things. All right, so the length of D to B, so that's the length from this corner here to this corner here. Across there we want to know. So best thing that we can do is we don't need to worry about these edges here. All we need to worry about with that is the square base. All right, so if that's D, that's C, that's B, and that's A. And we're told it's a square base, so that's 6 and that's 6. So if we go across there, then that's the distance from D to B. Now, we can, our old friend Mr. Pythagoras, so D to B squared equals 6 squared plus 6 squared. So D to B squared, we actually don't need this. So D to B squared, I say I don't need it because I'm drawing that like there, D to B with a line, so it's not, it's the length of that line then, so I don't need the D. So the distance would be, if I just did the points, distance from point D to point B, whereas here, because I've got the line symbol above, it's the line DB. So the line DB squared, the length of that, 36 plus 36, which of course is 72. And then when we square root both sides, the length of D to B into the square root of 72, which would be 6 root 2 in centimetres. All right, the length of B to E. All right, so when we look at that, I said that this is in the middle. Now, with this particular pyramid, you're told the slant edges are 10. So the slant edges are these slopey bits. Right, and they're all 10. They don't look like they're 10 because that's, again, two-dimensional piece of paper, three-dimensional object, but they're all a length of 10. So if that was D to B, and if they're all length 10, that puts this vertex straight over the middle, and so each side there, that would be the same. So here on this diagram, there's our E, and this are the same. So that's halfway, obviously, when I looking at in that way. So b to e is a half of d to b, which would then be, I believe, a half times 6 root 2, which would be 3 root 2 centimetres. All right, the length from V to E. All right, so the length from V to E, so that's from our vertex down to here. Now, remember I said before that drops straight down, so it makes right angles with the base. All right, standard vertical. So when we have a look and see in this, we can say, okay, so B to E we've just worked out. The slant edges are 10, and so then that's the height of our pyramid, which is the length of E to E. So we've got this triangle here. So take that triangle out and do that over here. So you take that triangle out, there it is, like so. That's the V at the top, this is the E, this is our B. All right, so B to E we've just figured out. Some more space, that's 3 root 2. And the slant lengths were 10. So we've got that, and of course that's a right angle there. So again, we can use our old friend Mr. Pythagoras, who says that 10 squared is equal to 3 root 2 squared plus V to E squared. So 10 squared is 100. 3 root 2 squared, 3 squared is 9, 2 root 2 squared is 2, so that's 18, plus V to E squared. Take 18 from both sides then, so V to E squared is 100 minus 18, which would be 100 minus 8 is 92, minus another 10 is 82. And so V to E would then be the square root of 82, and I don't believe that that can be simplified any off the top of my head. Don't think it can, so I won't try to. Of course, don't forget your units there, centimetres. All right, the last one part says the angle V to B to E. So when it talks of angle V to B to E, that means we're going from V to B to E, and of course this middle letter is where our angle is. So this is this same triangle, and V to B to E, and so this is the angle down here that we're talking about. Let's call it theta, and so D, part D. And when I'm doing this, I would always try and use the information we're given rather than something that I've calculated, if possible. So we know that cos of theta then is the adjacent over the hypotenuse, and so theta then would be cos minus 1 of 3 root 2 on 10, and that's a calculator job, and I believe my calculator says 64.8959, and 2 decimal places I'll go to 64.90 degrees is that angle down in that corner there, which is right in this corner up here. So the angle between the slant edge and the base is what that angle is. All right, so there you go. There's an example. So you try and use that strategy that I've tried to use there of taking the triangles out of the diagram, the three-dimensional diagram, and and go for there using whatever trig ratio or Pythagoras, whatever you need to use there. But the key thing is visualizing what it is that you've got, what it is that you want, and then take that out. I always take it out, draw a diagram. They don't have to be super accurate, but just something that you can visualize what's going on. All right, so if you need assistance with that, make sure you get it, and as always, have fun.